it's time to actually start drawing in 3D. For the first project, we're going to create this model, consisting of a floor, 2 walls, 5 other 3D objects, and a lighting source. This will give you experience working with some of the basic 3D tools and methods. Open your saved one project file. And check to make sure that you're in Top Plan, 2D Plan mode, and that your layer scale is set to 1/2 inch. Now we're going to create the floor of our model. Draw a 24-inch square. And duplicate it. Then align the squares. And set the fill of one square to 50% gray. If your colors aren't showing up, make sure that standard Vectorworks colors are selected. So far, this drawing looks exactly like last semester's 2D drawing. But if you select one of the 3D views, you'll see that Vectorworks thinks of 2D objects as flat 3D objects. Now's a good time to introduce the flyover tool, which is a more interactive way of viewing your model. Take a look at the different modes in the mode bar. Interactive Origin mode orbits around the drawing origin. And Object Center mode orbits around any currently selected object. Now let's switch back to a standard view mode to continue modeling. In order to create our first truly 3D objects, we're going to extrude our squares into cubes. Select both cubes and use the extrude command to extrude them -6 inches. Notice that they've now become wireframe objects. 3D objects in top plan mode always display as wireframe. If you switch to top view, they'll now appear as solid, because earlier we set the program to always switch to OpenGL when switching from top plan to other views. Switch to an isometric view to really see the effect of the extrusion. Extrusion takes a 2D shape and pulls it up or down into 3D space. There's also an interactive way to do this. Using the push-pull tool. But I generally prefer using the extrude command. Extrusion is one of the basic major building blocks of 3D modeling. Almost any shape can be extruded into a 3D shape. Basic extrusion is always perpendicular to the 2D object, and a positive extrusion number extrudes up, while a negative extrusion number extrudes down. The reason we extruded -6 inches is because this is a floor, and we want the top of the floor to be at 0, not at 6 inches above 0. That just makes it easier later on when we're extruding objects sitting on the floor. As a general rule, I always extrude floors in a negative direction. Now let's switch back to top view and continue with the floor. We're going to be duplicating these squares many times, but before we do that, we're going to turn them into a symbol. Call it floor cubes. And use all of the defaults. In 3D modeling, best practice is to create symbols anytime you know you'll be using multiple copies of an object. Multiple copies of symbols are more efficient than multiple copies of individual objects, and symbols greatly simplify making changes that may be needed later. We're going to be making about 150 copies of these cubes, and if we decide to change the color later, for instance, it's much easier to just change the one symbol than the 150 individual sets of cubes. To make one row of the floor, select your cube symbol, duplicate it, align the duplicate to the first symbol, and then duplicate 3 more times in order to create a row of 10 cubes. Select all of the cubes and group them. Now, duplicate the group and align the new group to the previous group. Flip this new group horizontally in order to create the checkerboard effect. Select both groups and group them, then duplicate the new group and align it to the previous group, and then duplicate 3 more times. Now, group everything together and switch to an isometric view to look at your work. Okay, looks good. Back to top. Since the walls in our model are identical to the floor, we can simply duplicate the floor, move it to the side, and use it as a wall. However, we need to rotate the wall so it's vertical. There is a 3D rotation tool, and that might be the way to go for some of you, but I think it's easier to just switch to front view and rotate the wall to the right. Now align the wall to the floor, noting that the wall sits on top of the floor, not beside it. Switch to top view and make sure the wall is aligned in this view as well. Note that when you move an object in one view, only 2 of the 3 coordinates are affected. Moving the wall in the top view does not change its previous alignment in the front view. In other words, if you think of this as the stage floor, from the top, you can move the wall upstage, downstage, stage left, stage right, but you have no way of flying the wall up or down in this view. You can only do that from the front view. But in this view, you can move the wall stage left and stage right, but you have no way of moving it upstage and downstage. Back to top. To create the other wall, simply duplicate the one wall, rotate it, and align it. Now let's switch to isometric to see the result. Because of this particular design, this may be a little disorienting, so let's use the flyover tool. Okay, looks good. If you're looking closely, you'll notice there's a little bit of weirdness in the pattern here, but if you think about it, it's mathematically impossible to line up 3 checkerboard patterns without one joint being off. So I've hidden it in the back. Back to top view. I want to stress here the importance of using snapping tools and smart cursor hints to make sure that things are actually aligned, not just close to aligned. Notice that in order to do this, I'm grabbing an object by a specific point, the endpoint, and moving it to another specific point. This is particularly important if you're going to use your 3D model in any real-world application like 3D printing. To complete our walls and floor, group all 3 items together. This completes part 3. In the next part, we'll add the other items and create a final rendering.